Hey y'all, Data Guy here. And today I have kind of a follow-up video to my previous video going through how to use Supabase and DuckDB for syncing, from kind of an application database to a production database. And today I wanted to take that to the next level with Neon and introduce branching, right? Because you branch your code many times a day without even thinking about it, right? But your database, typically you'll have exactly one or two, and many teams are terrified of actually changing it, right? Because every migration is a held breath, and every, let me just test this real quick, is a hand-rolled copy that you need to figure out how to merge into production. But Neon kills that fear, where it's serverless Postgres, and the trick is branching, as the headline trick, right? So full copy on write clone of your entire database in about 2 seconds, just one command. It's not an empty schema you remigrate, it's your real data isolated instantly. And that one feature changes who your database is for. It's a big part of why AI coding agents are starting to lean on Neon, because you can tell an agent to change your schema. And instead of running it on prod and crossing its fingers, it can fork the whole database, try the change on the fork, check the results against real data, and then throw that fork away. Production never needs to know about it. So here's the plan for today. We're going to stand up a Neon database and build a live pipeline that streams every change into a local DuckDB warehouse. So Neon's branching isn't just a claim, but you can actually watch data move through it. So then when we branch production and run a migration on the branch alone. And then to finish, we're going to build up an AI agent harness, watch it fork, test, and pass and fail a change, and then clean up after itself as well, so you can see how AI agents can also make use of these branching databases. So without further ado, let's get into it, starting off with the architecture. And so here in the architecture diagram I have up on the screen, right, we start with Neon because everything else is going to hang off of it. And the key, part of Neon serverless Postgres is, meaning one specific thing here that matters, right, is that it splits storage from compute. So our data is going to live in one layer, but the thing that runs our queries will live in another. And by decoupling those, it's going to let us do things a normal Postgres database can't. So we can scale compute to 0 when no one's collected. So an idle database costs us nothing, and also rewind a point in time. And we can branch, right? That's the critical feature for today. Because a branch only needs to point at the parent's existing storage and record what changes, Neon hands a full clone of the whole database in seconds, however big it is, and that's copy on write. And that's the feature this repo is built to show off. But a branch is invisible if you can't see data flowing through it, so that's where the rest of the stack comes in. We're going to stream every change out of Neon into DuckDB, just a local analytics database, and the mechanism is change data capture. And we're going to build it properly so we can actually capture change data through these branches, and the point of it is to make branching tangible, right? Branch production, change the branch, watch the difference appear live in a separate warehouse while production sits untouched. And the cast is Neon, again, for our source, the branching and agent workflow. Then we're going to have logical replication plus a plugin called wall2JSON to turn changes into JSON. And then we're going to use psychopg to talk to Postgres from Python, and again, DuckDB as our kind of backend warehouse that we're moving this to. And really what this is for is, for anyone that's scared to run a production against, or migration against prod, anyone who wants dev and CI databases that look like production instead of a stale fixtures file, and anyone wiring an AI agent up to a database who wants it locked into a safe, disposable sandboxed. So now let's get into it. So now you know the different points, right? The flow is going to be that someone inserts an order into Neon. Postgres is then going to record that in its WAL, its write ahead log, and our consumer is connected as a replication client. So Neon hands it that change already decoded into JSON by wall2JSON. The consumer then reads the JSON, sees this as an insert into others, and is going to run a matching upsert into DuckDB. Then it'll tell Neon, I've safely stored everything up into this point, and then Neon is free to recycle that chunk of the log. So now how do we actually build this in practice? Let's start with our Postgres side and our tables. So first, on the Postgres side, we are going to have two tables. So we have our application customers and our orders. So if I go into this init file here, you'll see here's just our basic schema, right? And this is basically just creating, a fake customer database. So we have our customers, we have our orders, altering the table. This is just doing updates and deletes, and creating publications, right? And so this is essentially, replica identity full is what makes Postgres write the full old row into the WAL on updates and deletes. So that's a really critical one here. And then after in the publication, Neon DuckDB pub is going to list what tables get streamed, and this is going to be applied to the make branch when I spin up the DB. So this is just making sure we know what tables are actually going to be streamed. Then if we go into turning on so then here just add region, this is a migration also we're going to run later, but I'll get back to this. But now what we need to do is, we have our database, we need to also set up a replication. And so for here, what we're going to do is enable logical replication for the whole Neon project one time via the API. And I'll show you our environment setup in a second. But essentially what here, logical replication is off by default. And so this script will turn it on with one API call. It's a patch that sets enable logical replication to true, flip the WAL level to logical, and it's project wide, so it'll apply to every branch, and it restarts your compute, so run it once up front. And then we also have apply schema. And what this will do is just take our SQL file and apply it against Neon over CycleBG with auto commit on. And we're going to use this later to set up branches. It's basically just going to take a SQL file and execute it against our Neon database. So really just a helper function here that we're going to use down the line in more practical settings. And then also what you'll want to set up here within this .env file that I've used is your database URL, Neon API key, Neon project ID, and all of these can be grabbed from the Neon connection details section in the Neon UI. So one sec, I'll show you where to grab that. So just go to Neon, choose your project, go to connection string here, and this will have all your connection string details. And then for API keys, your project ID, go to settings. And then for your API key, just go to your user settings and you can set up an API key there. It's really, really easy. So that's the setup there for the environment for Neon. Now back over into the code. Now next, I want to show you just our simulate script, which is just going to basically simulate a stand-in app that's going to write to Postgres when there's something to stream. So we have a few different functions here, right? So we have new customer, new order, seed. So seed is going to insert a starter set and run loops and fire weighted random inserts, updates, and deletes on these different objects against the table. So, new customer, this is going to create a new customer, execute that. New order, it's going to insert a new order. Seed, it's going to seed a bunch of them in a range. Pick an existing ID. This will allow us to select an existing ID to use. And then also run, this is just what's going to actually produce and simulate CDC traffic. So it's going to do all of those in kind of a semi-random order. And then we can see all of this just set up in this kind of main function down here, right? Which is just going to put it all together to just create, a set of orders and customers so that when we fire up the demo later, we'll actually see some customers come in live. Then what we're going to do is actually turn that stream of Postgres changes into the DuckDB warehouse. So here we have our CDC consumer. And so what we're doing here is first we have in order, insert all of our different packages and requirements. So CycleBG interacting with Postgres, DuckDB for interacting with DuckDB, and then these standard ones for JSON, OS interacting with our system. And then we're going to use a direct connection, not a pooled connection. And then the tables we mirror here are going to be the tables that we're actually going to use, right? So this will list the tables that we mirror, each one's primary key, so the consumer can identify a row on an update or a delete. And then down here, we have a function here for creating a slot. So this is creating a logical replication slot if one doesn't already exist with the wall2JSON plugin doesn't exist. So a slot will only capture changes after it's created. So the first time initial snapshot will read the existing rows, load them into DuckDB, and then this will make sure we have a replication slot for replicating changes into DuckDB. Then, going up here to line 185, we have apply change. And this will translate each wall2JSON message into SQL. So you can see kind of going through parsing out what the SQL message is, or the wall2JSON messages, and turning it into SQL. So inserts and updates become upserts, deletes removed by primary key, truncate clears the table. Because every write is an upsert, the snapshot and live stream then can overlap harmlessly as well. And then if we go back up here to CDC consumer and ensure columns here, so here, one function to kind of remember for later is this ensure columns. So before each write, this will add any column it sees in the stream that DuckDB doesn't have yet. And this is what's going to let a new column from a branch migration land automatically, which is the whole trick behind the branching and agent stuff we're going to do here. And then down here under on line 344, we have our consumer. And so basically what this consumer is going to do is on each commit, this is going to record the log position in CDC state inside the same DuckDB transaction, then acts it to Neon with send feedback. And so data and position commit together, so a crash at worst reruns the last transaction, which the upserts make safe. So that's our consumer. That's how we're setting up a replication slot. We're setting a translation function. We're making sure any columns are captured, and then also using CDC to state to capture the log position and make sure that a crash will rerun just the last transactions. Then what we need to do next is actually how we're going to query the warehouse and check on it. So what this function is going to be doing is, we're basically essentially just going to be creating a bunch of different queries for printing row counts and summaries so we can confirm changes are landing in DuckDB. And it's connecting with read only equals true. So we're connecting into DuckDB down here in main, right? And then we're basically just having these different commands to do select all to count and get aggregates amounts for all these different values. And then one just kind of gotcha here is a file only allows one writer or many readers, not both. So while the consumer holds the file open, querying it answer errors. And so this block tells you to stop the consumer, query, and then restart. And the slot keeps your position so nothing's lost. And then up here, we have this region block as well, which will only print once the branch migration has landed, which is exactly where we're headed, showing, hey, when we add a new column here to this branch. Now we have our actual branching file, right? And so this is essentially a helper file that's going to wrap the Neon CLI. So my demo's Makefile can actually drive branches and create branches. And so here, what you'll see is me setting up my authentication for the Neon CLI. So app key, project ID, role, database, the Neon CTL, then setting a requirement flag for require CLI. And then also Neon CTL. This is just a wrapper essentially to run a Neon CTL command with the project ID and API key injected. Then the exciting part of this is, hey, branch exists. So this is getting us a list of our branches. And then we also have our command to create branch. So what this will do is create, it's going to check if a branch already exists. If it doesn't, it'll run branches create with a parent. And that's the whole clone production step, right? It's just one command, create a branch. And then we have, const string down here. So this will create a connection string for the branch, right? So we added that connection string to our environment file. This is going to create a new one for the branch. And then down here, prep ties this together. So apply SQL, this is just a command to actually apply SQL through psychopg. But then command prep, or down here, ties it together. So this will create the branch, and then it's going to apply our schema, publication to it, then use that same apply schema helper from earlier. And then when it's done, it's going to print those exact commands to start a consumer against the branch. So what those commands will set are a different connection string, a different DuckDB file, warehouse dev DuckDB, a different slot name, different everything, right? Because we want everything to be replicated in this new branch, right? So that's the isolation, right? It's made concrete. Now we have a completely isolated new branch that we can test in and work on independently. So now that we have our new branch, how are we actually going to test this migration, right? And just going down here, the main function is just basically allowing us to call all of these. So again, nothing really that interesting down here, just wrapper function again for the Neon CTL. So if we go over to our file for DB migrations here, add region, right? This is the file I kind of flashed on the screen earlier. This is the migration we're going to test. We're going to add a region column to customers and then backfill every existing row with a random region so the change is immediately visible. It's the exactly kind of change you'd be nervous about running on production data. And then we go back to Neon branch, right? In line 160, we're not running this on production data, right? We are going to apply that SQL file to the branch and only the branch. And the comment, say it very plainly, the main is untouched. You're testing a real migration against a real full copy of the production data, but in total safety and in isolation. And so then also if we go down here, remember ensure columns from CDC consumer, if we go back up to line 131 here, so ensure columns, right? This is, where the payoff for that. When that new region column starts flowing through the branch stream, the branch consumer sees a column DuckDB doesn't have, and it's going to add it automatically, and we're never going to edit the consumer. The new schema just lands, migration, CDC pipeline, and warehouse will all handle that new column with no code changes. So then going back into our branch file here, so this is where we have the rest of the branch lifecycle, right? So reset will snap a branch back to its parent's current state. Restore is a time travel, rewinding a branch to how it looked at a past timestamp, and delete will just go and throw it all away. That's the whole CI dream, right? Branch from prod, test your change against real data, validate it downstream, then delete the branch like it never happened. So hold that loop in your head, right? Because you'll get something that's very relevant. And a human will run that, by hand in CI, but it's also the exact loop you'd want an AI agent running on its own before it's allowed anywhere near your production database. So let's also build that. So first, if we go into agent verify here and start, we have very similar setup, right? So a lot of the same packages, but the payoff here is, basically, hey, picture an AI agent told to add a region column. The dangerous version will run a migration on production and hope for success. This is a safe version where the agent can fork production, try the change on a fork, check it against real data, and then tear the fork down. And agent verify, this Python function, will run that whole loop in one command. So we can see up here, right, first thing you notice, it's going to import the real code. So it's going to import CDC consumer. From Neon branch, it's going to pull those command prep, migrate, connection string, delete functions. Harness isn't going to be a mock. It's going to drive the exact same pipeline and branching code that production uses. So if it passes here, it'll pass for real. And then if we go down here, so to line 188, under verify, right, if you don't name the fork, it'll auto-generate one. So agent verify plus a timestamp, disposable by default, and also line 190 will set and expires at up here. So basically say, hey, 2 hours out, there's a safety net that matters a lot for agents. So if an agent crashes halfway through, never cleans up, Neon deletes the fork on its own, so you won't wake up to 100 orphan branches. And then the actual core loop here. So command prep, forks production, make the CDC ready. Command migrate applies the candidate change to the fork only. Connection string hands back the new fork's connection string. Same functions, just now being called by code instead of you. And then if we go up to line 67 up here, you can see this is where we're actually, kind of putting the checks in, and this is where test against real data earns its keep. So we have PG verify is going to run 3 assertions straight on the fork Postgres. 1, that the region column still exists. 2, that the backfill left 0 rows still null or unknown. And 3, that every region value is one that we see, no surprise garbage. And then we go on to the verify, right? So back into line 92 here, right? So on agent verify, we have essentially the option to say, hey, the comment here is the entire argument for forking, right? Because this is the entire bug you can only catch against real data volume, not an empty table. And an agent testing against a blank scratch database would see the column exists and then call it a day. But an agent testing against a fork of prod runs the backfill across every real row and can notice if even one gets missed. And so that real data is what's going to make this test really meaningful. And then going down here under CDC verify, this is a migration that's perfectly valid in Postgres. It could still blow something up downstream. So CDC verify goes even further. It loads the forks data into a throwaway DuckDB using the same open warehouse and initial snapshot calls the consumer uses. Then it checks the region column, made it all the way through. And then we have agent verify line 128 here. Our old friend from chapter 4, right before, is the path that runs in sure columns. The warehouse now auto adds region on the way in. So the check is really asking, does the new column survive the full trip from a migrated Postgres fork all the way to the analytics warehouse? If a change renamed a column or used a type the DuckDB hated, this is where that would fail. Then down on line 213, back down here we have the verdict, right? It'll print pass or fail for every check, then 1 overall pass fail, and this is the bit an agent will read. On pass, it says the change is safe to promote to main. On fail, it says the change is rejected and main was never touched. And machine can branch on that line, and that's the point of printing it that way. And then down here, line 226, right, this is where the teardown lives. In a finally pass, fail, or exception, the fork gets deleted on the way out. The only escape hatch is keep for when a human wants to climb into a failed fork and poke around. Otherwise, production's left exactly as we found it. And then finally, here is the difference between a tidy agent and one that litters your Neon project with dead branches. So that's the whole agent loop. Now, let's see how you can drive all of this. So putting this all together, now we have our Makefile, right? And this is essentially just standing up everything that I just talked about, right? So seeing that database, setting the database up, setting up branching, activating it all, setting up all those scripts, making them available. I think really the big call outs here are, the interesting targets that isn't just kind of standard Makefile stuff, is branch consume here, because it'll show the isolation in a plain shell. It'll ask Neon branch for the branch's connection string, launch the same CDC consumer we've already built, but with 3 environment variables overridden. So the DSN points at the new branch, DuckDB is warehouse dev DuckDB, and slot name gets a per branch name. And so it's the same consumer code, but pointed at a different branch, writing to a different file. The program itself has no idea it's running against a branch, which is the right design. And then right below this is agent verify. So this is the one-liner for the whole agent loop we just built. No branch needed. It names and destroys the fork for you. There's a keep one flag if you want the fork to survive for a look. So one command and it's full fork test verify teardown. And now what we'll do is just set up with make demo. So now if I go and run make demo and switch into my terminal, So the first thing we'll do to actually start demoing this is just run make demo, right? And this will show our basically setup, right? So we're going to make install, right? Which is just kind of, basically set up. And I've already done this to, actually init, seed, do everything there. Then I'm going to show you simulating CDC, producing traffic on main, the copy on write clone, and then adding the column. So we're going to demo everything that I just built. So the first thing we're going to run here is make consumes. You see I just hit run and it's created the replication slot, Neon DuckDB slot, and it's creating the initial snapshot. Snapshot's going to load 5 rows from app customers. Then it's going to connect to Neon. It's create a streaming slot there, right? So this starts the main pipeline, right? So it's going to then sit and wait on the stream. So everything, is from up to essentially the part in the video where I set up the CDC consumer is all running now. So we have our CDC consumer up and running, but now we actually need to start simulating things and making it do some exciting stuff. So now if we open up another terminal here, we will run make simulate. So if I run make simulate, now we have production is alive. So we're going to have, and you can see insert orders are going to start streaming in. So inserts, updates, deletes. And now if we go back to our first terminal window, you'll actually see these showing up instantly as it's getting written into DuckDB. So it's CDC, there's no batch job. The warehouse is current to the second, and it's all being driven through Neon. And then part 3 is going to be the headline here. So if we go and I create another terminal window here, and I say I want to make branch equals dev, right? What this is going to now do is take my credentials, and we're going to have a full copy of production in around 3 seconds. So even quicker than it took me to finish that sentence, right? Full copy production, all the data isolated, actually already created this. So you can see our branch is now ready for CDC. So we can run the consumer against it now with these details. So now if we go and run make consume branch equals dev, right, you'll see this will now create a second pipeline streaming the branch into warehouse dev.duckdb. Now we have 2 independent CDC pipelines running side by side, never touching each other. And then if we want to do a make branch migrate, so just give this a second running, go to new window, run this make branch migrate branch equals dev, you'll see this is going to now apply that migration to our branch. So now we've added a new region column on branch only, and we can watch the branch consumer now in plane 3, and you can see these changes now start in streaming in. So you can see branch EMEA, or region EMEA added to these users, right? So this is the ensure columns doing its job live, making sure that the new column appears in the output, lands in the branch warehouse all by itself. And now if we go and actually query the warehouse, so now if I go into another window and run this DuckDB, make query, you can see I have all of my new information set up in with my new region in my new account. So you can see here my branch migration landed. Actually, sorry, you can't see it. Let me move my screen. So yeah, down here, you can see that we now have our customers by region, where we have our regions assigned to our different customers, and we're able to see that. You just can't see it in the columns here because there's just too many columns. But you can see it when we search by region. So really, really awesome job here. And honestly, only possible because of Neon. So now we're done, right? So we can, make branch delete branch dev, right? And delete this branch down now. And now the clone is gone like it was never there, right? And that's the workflow you want for scary migrations. Now, let's say we want an agent to actually do it, right? So remember the whole thing, we did all that by hand, right? A lot of different terminal commands to run. But let's say we want to have our agent actually run it with make agent verify. So first just clear this window, then set up make agent verify. And you'll see this is going to go through and it's going to create and set up all the things that we did before, but in a way that will let an agent interact with it really easily, right? And you can see our DuckDB warehouse being created, destroyed there, the exact same flow that we just ran, but just having an agent do it, right? So it's able to fork production into an agent verify branch, then it's going to pass the migration, apply the migration to the fork, then the checks fire, right? The region column exists, pass, backfill, complete, pass. You can see these passes down here, region values, and it snapshots the fork into a throwaway DuckDB and confirms the column made its way downstream. And then the verdict line, right? We're going to pass it, save from road to main, and that's the line an agent reads to decide its next move, right? If it handed it a broken migration, that line would say fail and it'd be rejected, and main would have never been touched, right? And then, looking at the last line, fork's already gone, it cleaned up after itself because the teardown lives in a finally. So the agent fork production tested a real change against real data, gave a clean yes or no, and left nothing behind. So it's the safest way to let something automated near your database. So that is everything I wanted to show you in this video, right? So pulling it all together, a change happens on Neon Postgres, right? And we were able to take that all the way to our backend Neon database, right? Logical replication, put it in WAL to JSON, turn it into JSON. Our consumer applied it to DuckDB as an idempotent upsert, record its position atomically so a crash never loses data. And that's the whole pipeline. And Neon branching let us clone all of the production data in seconds, run a second pipeline against the clone, and test that real migration without ever putting any load on production. And then an agent was able to do the exact same thing, right? So if you want to try this out for yourself, you want to play around with having different databases for different agents or different apps. I also have another really cool video where I show you how you can have a different database per user or per agent automated too. So Neon is going to be the place to go. So if you go to neon.com, hit get started, you can spin up an account right here. And I definitely encourage you to do so if you're looking to do anything like what I just showed you today around migrations. So I hope you enjoyed this video. I hope you have a great rest of your day. Data Guy out.